Activity 5. To show that when a metal reacts with water, hydrogen gas is formed. Things needed: a sodium metal piece, filter paper, 250 ml beaker, blue litmus paper, red litmus paper, some water. Method. We know because sodium metal reacts vigorously with oxygen and water, it is therefore stored in kerosene. We cut a small piece of sodium and remove the kerosene by pressing the piece between the folds of a filter paper. We take a 250 ml beaker. Fill half of it with water. Now, put the piece of sodium into the beaker. Observation. The sodium metal floats on the surface of water and at the same time melts to form a silvery white ball. The silvery white ball of sodium darts over the surface of water with a hissing sound, producing tiny bubbles of hydrogen gas. The silvery white ball gradually becomes smaller in size and catches fire. It burns with a golden yellow flame. The solution becomes hot. This is because the heat evolved in the reaction melts the sodium metal and the hydrogen gas produced catches fire. After this reaction, if this solution is tested with blue and red litmus paper, the red litmus paper turns blue. This shows that the solution is basic in nature. The chemical equation involved in this activity is given as sodium plus water reacts to give sodium hydroxide plus hydrogen gas plus heat. Conclusion. When a metal reacts with water, hydrogen gas is formed. Activity 6. To show how metal and non-metals react with dilute acids. Things needed: a magnesium ribbon, aluminium foil, iron nail, copper wire, coal piece, sulfur powder, 6 test tubes, dropper, dilute hydrochloric acid, matchbox. Method. We take samples of metals like magnesium ribbon, aluminium foil, iron nail, copper wire, coal piece, sulfur powder in separate test tubes and label them as A, B, C, D, E and F. With the help of a dropper, we add 5 ml of dilute hydrochloric acid to each test tube one by one. We observe the reactions carefully. We bring a burning matchstick near the mouth of each test tube. Observe the burning matchstick carefully. Observation. Reaction of metals and non-metals with acid. Magnesium reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. Magnesium plus hydrochloric acid dilute react to form magnesium chloride plus hydrogen gas. Aluminium reacts with dilute hydrochloric acid, forming aluminium chloride and hydrogen gas. Aluminium plus hydrochloric acid dilute react to form aluminium chloride plus hydrogen gas. Iron reacts slowly with dilute hydrochloric acid to give iron oxide and hydrogen gas. Iron plus hydrochloric acid dilute react to form iron chloride plus hydrogen gas. Copper does not react with dilute hydrochloric acid at all. Copper plus hydrochloric acid do not react. There is no reaction. Non-metals like coal and sulfur do not react with hydrochloric acid at all. Coal plus hydrochloric acid, no reaction. Sulfur plus hydrochloric acid, no reaction. Conclusion. Reactive metals react with acids and produce hydrogen gas that burns with a pop sound. Less reactive metals like copper, silver and gold do not react with acids. Non-metals also do not react with acids. To show that reactive metals react with solution of bases to form hydrogen gas. Things needed: a test tube, 3 to 4 pellets of sodium hydroxide, plastic spatula, aluminium foil, matchbox. Method: we take a test tube and drop in it 3 to 4 pellets of sodium hydroxide base with a plastic spatula. We add 5 ml of water and shake the test tube containing sodium hydroxide well. We have prepared a fresh solution of sodium hydroxide. To this solution we add a piece of aluminium foil. We can see tiny bubbles of gas in the solution. Observation: we bring a burning matchstick near the mouth of the test tube. The gas catches fire with a pop sound. The pop sound indicates the presence of hydrogen gas. The chemical reaction involved in this activity is aluminium plus sodium hydroxide plus water react to give us sodium aluminate plus hydrogen gas. Conclusion: reactive metals like sodium, potassium, aluminium react with solution of bases to form hydrogen gas. First, click on beaker to place it. Click on distilled water bottle. Click on copper. Pick up spatula. Stir the contents in. Click on the test tubes. Pick up the beaker with copper sulfate solution. Click on the clamp stands. Click on the test tubes. Click on the iron nail. Drag. Click on thread. Keep the test tubes undisturbed for about 15 minutes. After 15 minutes, remove the iron nail from the solution. What do we observe? We observe that the solution in test tube A has turned green, but in test tube B it retains the same blue color. This is because of ferrous ions in test tube A, which came from the iron nail due to displacement reaction, whereas in test tube B there was no nail and hence no displacement. We also observe that the dipped iron nail has become brown, whereas the other nail retains its greyish color. This is because of deposition of copper metal on the dipped iron nail due to displacement reaction, whereas the other nail was not dipped in the copper sulfate solution and hence retains its color. What is the reason behind the changes that appeared? Uses of metals and non-metals. Oxygen is essential for all living organisms. It is needed for respiration. Non-metals like nitrogen, phosphorus, etc. are used in fertilizers to enhance the growth of plants. Graphite is a good conductor of electricity and is therefore used as an electrode in electric cell. Graphite is used in the manufacture of pencil leads. Diamond is used as a gem in making jewelry. Sulfur is used in the manufacture of dyes, matches, fireworks, and gunpowder. Chlorine is used to disinfect water as it kills germs. Iodine in iodized salt prevents goiter disease. Tincture iodine is used as an antiseptic. Phosphorus is used for the manufacture of matchstick, rat poison, and fertilizers.